is on addition reaction of alkenes. Now, alkenes, because they have the double carbon bond, they will go through three types of addition reaction. One, hydrogenation with hydrogen, bromination with bromine, aqueous bromine, and hydration with steam. So now what we're going to do is going to study the reactions of these three with alkenes. So let's look at the first one, propene. Propene has a double bond, C3H6. When hydrogen is present and you need a nickel catalyst, what happens is the double bond opens up. This double bond will break and it opens up. Okay, when it opens up, hydrogen will as well dissociate and will be attached, and that's what you get. Two hydrogens, pink color hydrogens, and what you get is a different homologous series altogether. Here you get propene, and now you get propane. So hydrogenation actually changes an alkene to an alkane. So it becomes another homologous series, alkene to alkane, because it adds two hydrogen inside, and you get a saturated compound. This is unsaturated. Bromination. Okay, let's take another one. This is butene with the double bond in the center, and it goes through an addition reaction with bromine. When this happens, this is known as bromination. What happens is the double bond breaks, one of it breaks, and we get this, something like a doll swimming often, and the two bromines will be attracted, and this is your final product. Because it has two bromine, it is known as dibromobutane. Okay, this is known as bromination. Now, common mistakes that people make is this. Okay, let's take one example. This is an organic compound. It looks like a butene, but there's an X there. It's an unknown molecule there. Double bond here. So what you do is you break here. This is what you get. When you break, you draw everything as per normal. Okay, this is where the bond is. If you break, one will be here, another one will be here. So how would the bromine be attracted? Since the line is here, bromine will be here. And if you remove the bromine and close up, you should get back the same thing. Let's look at this one here. If you break the bond, draw everything first, just to see. If the bond is broken, you get two bonds here, two new bonds here. Bromine will be attracted and bond there. So notice this compound and this compound is different. The Br is on the last two, the Br is on the second and third. Two different things. So if in the question they give you, they put the double bond on the right hand side, you've got to get this compound. If you put it in the center, if the question gives you the double bond in the center, you've got to put the bromine on the second and third, not on the last two. Okay, the last reaction for alkanes. Alkanes will react with steam, and what happens is double bond will break as per normal. Now one of the hydrogen will be attached here, another hydrogen will be attached on this side, or if I just switch it around, it's here. Now notice that when oxygen breaks, if I slice this off, I will get hydrogen and a hydroxide, something like a hydroxide, an OH group, but it's not a hydroxide. Hydroxide is OH minus. So in this case, we need a catalyst known as phosphoric acid. Okay. In the case of butene, the double bond is on the second and third atom, and the point of attack will be on the second and third. Notice that it is always the oxygen that is connected, touching the carbon, and not the other way around. If you put a H, if you do something like this, this will be wrong. Because where you cut is where you join in. So where you cut is on the between the O and the H, not on the H itself, not on the outside of the H itself. Okay, so where you cut is where you join back. So hydration changes an alkene to an alcohol, and the name of this will be propanol, propene propanol. And remember, this takes place at a higher temperature where water is steam and the catalyst is H3PO4.